Hey everybody, in this video we are kind of stepping off from the last one and we are graphing reciprocal functions, but specifically the reciprocal of x squared, not of x. So it's going to have an impact on the graph. So another name I commonly use for this graph is called the volcano, because it kind of looks like a volcano. This one might be in some sense easier to graph because it's not convenient to plot more points than really just two and just draw the branches. It doesn't have that same trick or characteristic that you have in 1 over x, where you can just pick things that multiply to give you a. So because of that, we kind of do a little bit less. So, and the last one, the type of symmetry was odd. I don't think I put that on there. This one, the symmetry we have is even, like quadratics. It's symmetrical down the middle like a butterfly. As x, I'm just jumping all over the place. As x approaches negative infinity, as we go to the left, what is happening to your graph? So as we plug in more and more negative numbers, negative 10, negative 100, negative 1000 in for x, what happens? Well, we square those numbers, they become positive and large, and we have 1 over bigger and bigger numbers, and that means that fraction of 1 over a larger and larger number gets closer and closer to 0. The exact same thing happens on the right, because it's already positive, squaring it stays positive. Okay, so because of all this, we are going to have x still can't equal 0, so we're going to have a vertical asymptote at 0. X can't equal 0, so this is off limits, so there is a vertical asymptote right there. Asymptote, asymptomatic, no characteristics of the graph. And as for the end behavior, because we're getting closer and closer to 0 as we go out to the sides, we can draw in what we call a horizontal asymptote at the line y equals 0. X equals 0, y-axis, y equals 0, x-axis. And really we're just going to focus on 2 points. We're going to go over 1 unit, fill it in. 1 for x, 1 squared is 1, 1 over 1 is 1. Same, negative 1 squared is positive 1, 1 over 1 is 1. And that means we're doing blue for this graph. Sorry. There we go. There we go. And there you go. That's the volcano. The limit as x approaches 0 from the left. As we approach 0 from the left, what y value are we getting closer and closer to? Well, none specifically. It doesn't really exist. So we write infinity. And as we approach 0 from the right, what's happening? Well, that still doesn't exist because we're not hitting a certain specific value. We put infinity. If you are in calculus at this point, if you were asked in general the limit as x approaches 0 of 1 over x squared, the question, does the limit as x approach 0, does the limit exist? The answer is no. Even though you would answer the question positive infinity, that's what you would write down. Infinity or negative infinity is a form of does not exist. It falls under the does not exist umbrella. And that's usually a concept that people can't always wrap their heads around. So there we go. Now, why do we not do multiple points? If I fill in 2, I get 1/4. So it doesn't work the same way where I can plot those points. If you know what I'm talking about, it was referenced in chapter 9, the reciprocal. Okay, so we're only going to focus on those 2 points because they easily manipulate. So the next example, right to the right of it, all we have is a vertical reflection and vertical stretch of 2. So I'm going to go in and draw in my asymptotes first. They did not move. No left, right, no up, down transformations. Vertical asymptote right here. So now I'm worried about these 2 points. That's it. They reflect and they stretch. So they stretch, instead of being 1 unit away, they are 2 units away, and they reflected. So now we have a bit of an upside down volcano. Now the other points, they're not precise because we didn't plot any. If you need to, just plug in some numbers. It's not that bad. Okay. Even if there's transformations, I would say plug in the numbers prior to shifting left, right, up, down, and then adjust them according to your new x and y lines on these asymptotes. And that's it. Let's look at 2 more. Okay, here I will color code the shifting. X plus 7 left, 7, 2, 4, 6, 7. Then down 2. Okay, the 4. Vertical stretch of 4. So there's no flipping, so I'm going to be in these two quadrants. So instead of over 1, up 1, I'm over 1, up 1, 2, 3, 4. Over 1, up 1, 2, 3, 4. Good enough, good enough, good enough. And there you go. Beautiful, gorgeous, amazing. And one more. Right 6, 2, 4, 6. Up 4, 2, 4. Vertical reflection. And a, can I write over here? Vertical stretch of 5. So 1, 2, 3, 4, 5. 5. And there you go. That's it. All finito. So the reminder on the bottom of this page was you only want to use your vertical and horizontal asymptotes and 2 points, 2 ordered pairs for this particular graph. Thumbs up if you get it, got it, and you're good. Thumbs down if you hate it, I don't care. Questions, comments, concerns, put them in the bottom. Help somebody else, answer yours, answer somebody else. I'll try to answer them. And the next video, I'll be going over how to graph polynomials very quickly. Again, I have tons of videos graphing polynomials, but this will be a crash course like this one, chapter 11 we can call it. Isn't that bankruptcy? Chapter 11. And then chapter 12, I think I might do trig stuff, and then after that, rational. Okay? Sayonara.